Okay, today is September 26, 2011. We're on lesson 1.5. We're going to do example number 1. All of these are problem-solving questions. So the first one says, Christian has a total of 8 cars and trucks to play with. His birthday is soon. It's irrelevant. He hopes to double the number of cars he has now. If he does, he will have a total of 11 cars and trucks. How many cars does he have now? How many trucks? So I've read it through once. I have an idea of what he's talking about. Always read problem-solving questions twice. We have to set up our variables now, and then we have to set up our equations. So first of all, Christian has a total of 8 cars and trucks to play with. So he has cars and trucks. So I'm going to say, let C represent the number of cars he has. Okay? Let T represent the number of trucks he has. Okay? So the two variables I'm going to use are C and T. And the very first line tells us one of the equations. It says that Christian has a total of 8 cars and 8 trucks, which means if I add all of his cars plus all of his trucks, how many vehicles are there altogether? 8. So there you go. That is our very first equation. C plus T is equal to 8. His birthday is soon. That's nice for him. He hopes to double the number of cars he has now. So, he wants to double the number of cars he has now. What does that mean? How can I set up a little term to represent this? 2C, that's right. Cars are the amount of cars he has now, and he hopes to double them. So he'll have 2C, and we've got to figure out the rest of the equation. It says he hopes to double the number of cars he has now. If he does, he will have a total of 11 cars and trucks. So, are the number of trucks changing?
No.
No. So we're still going to add 2 times the amount of cars plus trucks, and he'll have 11 vehicles in total. Okay, so I have my 2 equations. What are the 3 ways I can solve a linear system?
Elimination.
Okay, so I can use elimination. What else can I use? I can use substitution. And finally, that's right, I can graph. We have 3 different methods to solve these, okay? What I'm going to do now is I'm going to start by graphing. I'm going to graph this question specifically. So let's get a graph on your page. Okay, so I have a graph. I put it to 20s. There it goes up to 20. Now, here's what's important about graphing. We have 2 axes. One is called the Y, and the other is called the x-axis. If you look at the variables we have, we're using C and T. We are going to have to choose which of these is going to be C and which of these is going to be T. I'm going to decide that C is going to be X. Okay? So I'm going to change it. I'm going to change it so that C becomes X and T becomes Y. So I'm going to rewrite the equations over here. C now becomes X. I'm going to write it on top. And T will become our Y's. So my new equation is X plus Y equals 8. And equation 2 is 2X plus Y equals 11. Now I'm dealing with my X and Y axis. This will be a little easier to look at. Now, in order to graph something, I have to put it into a specific form. I have to set it equal to a specific variable. Which one? Yeah, I need it to look like y equals mx plus b, or in other words, I need to set it equal to y. So I have to rearrange both of these equations. So, very first equation, to set it equal to y, all I have to do is move the x to the other side. So our new equation 1 becomes y is equal to 8 minus x. And again, to set this equation 2 equal to y, I just got to move over to x. So I'm left with equation 2, y equals 11 minus 2x. I need to recognize what my y-intercept is and what my slope is. So We're going to do slope in blue. In equation 1, what number represents slope? Negative x, or what that can be considered? Yeah. Yes. Imagine there is a 1 there. So that negative x is really the same as negative 1. So for equation 1, our slope is negative 1 over 1. What about in equation 2? What is our slope? That's right. We have negative 2 over 1. That's this number here. Okay? And I need a y-intercept, or a b. In equation 1, what is my b? Positive or negative? Positive. And what is my b in equation 2? Positive 11. Good. So now in order to graph these, first I need to find the y-intercept. So equation 1, our y-intercept is the number 8. So I put a point on 8. Okay? And what happens is we need to follow the slope. So we need to go down 1, over 1. Okay? So when we do the slope, as long as we've set the numbers up equivalently, which we've done, everything's going up by the factors of 2. We're going to go down 1 and over 1. Down 1 and over 1. Okay? Really, down 1 and over 1 is going to look like this. It's going to be halfway in between. Okay? Because I'm going by factors of 2. But because our y and x axis are counting by the same numbers, I can just jump a step. If your intervals for the y-axis and the x-axis are different, you cannot use that method and just go down 1 over 1. You actually have to count the numbers. Okay? So I started at 8. 7 is halfway in between. And 1 over is halfway in between. I still ended up on the same slope though. So I'm going to start here. And we have the slope of our first line. Okay? Now for our second line, our y-intercept is what number? 11. Okay, so our slope for our second line, we'll do it in red, is 11. 11 is halfway in between. And the slope for this one is down 2. So that'd be 1, 2 over 1. Our slope more looks like this. 1, 2 over 1. 1, 2 over 1. 1, 2 over 1. 1, 2 over 1. And then roughly here. So the slope of our second line, I'll do a dotted. Looks like that. So we have our two slopes. And we discovered our point of intersection. We discovered our point of intersection is right there. Does anyone know exactly what spot that is on the graph? 5 and 3. Because we went by intervals of 2, so we go 1, 2, 3. My x value was 3. And when I go up, I go 1, 2, 3, 4, and in between would be the number 5. So my y value would be 5. So I've solved this linear system by putting x at 5 and y at 3, which makes sense. If we had to figure out how many cars, remember x represented our cars. I'll throw that down on the side. Cars and trucks. Let's just check to make sure. If he has 3 cars and he has 5 trucks, how many vehicles does he have in total? 8, just like we said at the beginning. And if he doubles the amount of cars, how many cars will he have? 6 cars. And then how many vehicles will he have then? Yeah. So these two numbers work perfectly when we plug them back into the equation. It says Leanne works at a greenhouse. She needs to plant a total of 32 bulbs. 2 types of bulbs are available. She's asked to plant 3 times as many crocus bulbs as tulip bulbs. How many of each should she plant? Okay, so let's reread it again. She's told to plant a total of 32 bulbs. Okay? So we know that crocus bulbs plus tulip bulbs are going to be what? 32. So the total amount of bulbs, crocus, plus tulip bulbs would be 32. The other equation is not as simple to see, but it is a very simple equation. She's asked to plant 3 times as many crocus bulbs as tulip bulbs. How would I set that up as an equation? So for every crocus bulb she plants, she's asked to plant 3 times as many crocus bulbs as tulips. So sorry, for every tulip she plants, how many crocus bulbs are planted? 3 crocus bulbs are planted. So we now have equation 1 and equation 2. Okay? Okay, example number 2. A canoeist took 2 hours to travel 12 kilometers down a river. The return trip against the current took 3 hours. What was the average paddling rate excuse me, of the canoeist? What was the speed of the current? Okay, so first of all, let's deal with the distance. How long is this river? We'll repeat it again. Page 44. A canoeist took 2 hours to travel 12 kilometers down a river. So we know that the distance is 12 kilometers on the way down the river. So let's say we're going this way down the river. How far is the distance on the way back? 12 kilometers. Okay. It took, in time, how long did it take them to go down river? 2 hours. How long did it take them to get back? 3 hours. So, when you're on a river, what that means is the river either helps or hinders you when you're traveling. So when we were going down river, was the river helping or hindering? Helping. They were helping because it took them less time. So that means our average speed was helped. So our total speed, this is total speed. Our total speed is our average speed plus the speed of the river. I don't know why I put P for average speed. We're going to say S for average speed and R for river speed. And on the way back, we had our average speed again. We assume we're traveling at the same rate. But this time, the river was slowing us down. Okay? So the river slowed down our total speed. I forgot to give us a let S. So let S be or represent average speed. And let R represent river speed. Okay? So when we go to set up this equation, we now know, and whenever we're doing traveling, that your total distance is equal to your speed times your time. So distance equals speed multiplied by time. Now we've set this up. We know our total speed is going to be this, and our time is this. Okay? So for our equation 1, our distance is 12 kilometers. Our speed is our average speed plus the river speed. And we have to multiply that by our time. How much time did we spend? 2 hours. Equation 2, same distance. This time our speed was hindered by the river, and it took us 3 hours. Okay? So, now that we have our 2 equations, this one we'll solve by substitution, okay? Or actually, you know what? This one will be easy to do elimination with. So, out of our 3, we can eliminate, substitute, or graph. We're going to eliminate for this question, okay? So, equation 1, I need to actually distribute the 2 into both variables and distribute the 3 into both variables. So this question now reads, 12 is equal to 2s plus 2r. because I distributed the 2. And 12 is equal to 3s minus 3r. Now I need to eliminate, which means I need to set this up to get rid of a variable. So I'm going to get rid of our average speed, our s, and isolate on r. So that means I'm going to multiply the first equation by 3, and I'm going to multiply the second equation by the number 2. I'm doing vice versa. This equation I multiply by this coefficient, and this equation I multiply by this coefficient. Okay? So, our new equation for equation 1 is 36 is equal to 6s plus 6r. And equation 2, 36 is equal to 6s minus 6r. Now I said I wanted to get rid of our s. So what do I have to do to this equation to get rid of the s? Subtract. Okay? So let's subtract these numbers. So I made a mistake when I was multiplying. 2 times 12 is not 36. 24. So when we go to subtract, we're going to subtract these numbers. 36 subtract 24, 12. 6s subtract 6s, 0. 6r subtract negative 6r, 12r. Okay? So when we bring the 2 together, we get r is equal to 12 divided by 12. R is equal to 1. So we know that the river's speed, we discovered that the river's speed is equal to 1, and we assume it's kilometers an hour. Okay? Now we need to find our average speed. So we'll do elimination again, and it just so happens I can use the exact same formulas that we had before because the coefficients are the same. But instead of subtracting, I'm going to add. That way I get rid of the r's and I isolate the s's. That's supposed to be a negative. So again, we're going to eliminate. This time I'm going to add these together. So 36 and 24 will be 60. 6s plus 6s will be, and 6r plus negative 6r is 0. I'm left with s is equal to 60 divided by 12. 5. So our average speed is 5 kilometers an hour. Okay? So our average speed is 5 kilometers an hour, and our river speed was 1 kilometer per hour. When we set these two up. Sure. Example 3. Miriam has a bottle of 5% acetic acid and a bottle of 10% acetic acid. How much should she use to make 250 milliliters of 8% acetic acid? So first of all, we're going to put, let X represent the 5% solution. Okay? Let Y represent the, what was the other one? 10%? 10% solution. So I know that all of the 5% solution in milliliters plus all of the 10% solution in milliliters is going to equal 250 milliliters. Now what we want to do is find the acidity. So we've figured out the actual amount of solution. This is amount of solution. Now we got to find pure acid, we'll say. So, to find out pure acid, we need to convert these into decimals. So we know that if we multiply the amount of our 5% solution by 0.5, that will give us our pure acid. And if we multiply our 10% solution, the amount in milliliters, by 10%, we'll get pure acid. And finally, we're trying to make an 8% solution. That's going to be 250 milliliters. So I multiply 8, or 0.08, times the 250. So I have equation 1 and equation 2. Now, we're going to try to solve these by substitution. Remember I said there's 3 different ways. We've done graphing already, done elimination, and now we're doing, not graphing, substitution. So, in order to substitute, I'm going to, let's say, set this equal to x. So I'm going to move the y to the other side of the equation. So I'm left with x is equal to 250, subtract y. That's equation 1. Now I need to plug this value of x. We know that x is equal to 250 minus y. I need to plug it in to the variable x in the other equation. So equation 2 read 0.05x plus 0.10y is equal to 0. Now we can actually solve this other part. We'll write it down as the way we had it before. Times 250. I'm going to plug this value in for the x right there. So I get 0.05 times 250 minus y plus 0.10y is equal to, and let's solve this other part. Is that what it is? 20? 0.08 times 250? Oh, genius. 20. We're then going to distribute 0.05 to both of the terms inside the brackets. So what is 0.05 times 250? So we get 12.5. 0.05 times negative y will be negative 0.05y plus 0.10y is equal to 20. I'm going to get all my variables on the left side, which they are, and I'm going to move the 12.5 to the other side of the equation. So I get 0.05y plus 0.10y is equal to 20 subtract 12.5. 0.05 or negative plus 0.10. So let's do that. 0.05 negative plus 0.1 equals positive 0.05. Y. And this will be 7.5? And 5. I need to isolate for just y, so I need to divide by 0.05. Y equals 7.5, divided by 0.05. Y equals 150. So, our y represented our 10% solution. Apparently we needed 150 milliliters of that. I still have to figure out how much of the other solution I need. So I'm going to substitute 150 in for the y and solve for the x. So remember the other equation we had, this is the easier of the two. X plus y equals 250. Our y value is 150, so I'll plug that in for the y. X plus 150 equals 250. When I move the 150 to the other side, I get x is equal to 250, subtract 150. X is equal to 100. So I need 100 milliliters of 5% solution and 150 milliliters of 10% solution to make 250 milliliters of 8% solution. I'm going to give you your homework.